over to the book where all the problems are for section 9.3, which were the two up here, 3 through 14, which we already talked about a little bit yesterday, but I wanted you guys to grade the evens and make sure you got them right. That's on the left. And then last night's homework, 17 to 23, 25 to 28, and 31. And a quick heads up for everyone, we are grading everything 9.3 tomorrow. And some of you have been getting more and more organized, which is great. So if you have that like stapled ready to go tomorrow, like 9.3, A, worksheet A, homework, B, worksheet B, homework, or if you have your homeworks nice and neat in your homework spiral, you can just turn from one to the other and show me in your worksheets. You can show me. That will make tomorrow's grading so much more efficient. So anyway, the ideal. Let's grade homework. Let's talk about where you got stuck in homework before we go to section 9.4, notes. But as you guys are grading, there is a big question I had on the board when you guys walked in. I'm going to put the evens back up. But on your worksheet, there's a big question. It's actually kind of awkward up and to the right. I see hands. Just give me one second. I want you to, if you're not grading homework, ponder that question and circle the one that you think would be easier to solve. There was a big question up on the board. It's on your worksheet. Jamie, can I borrow it? It's right here on your worksheet. If you guys aren't grading your homework or if you don't have any homework questions, I want you thinking which one looks easier to solve. Don't worry, it won't be like a quiz where you have to solve it or else. Which one looks easier to solve? Questions? Jerry?
I'll go think of the back real quick.
Yeah, just don't get lost in the quick. Don't want you to miss too much. Anything else? Okay, are you circling the one that looks easier? Oh, good. I think a lot of you are circling the same one. Which one would you circle? Which one looks easier? And as you're pondering which one looks easier, I'm going to ask if there are any homework questions from last night. And you can be looking at the one that looks easier, and you can actually, if you think, don't worry, it's not a first grade, but if you think you know how to start it, why don't you start trying to solve it? Which one do you think looks easier? And do you know how to start solving it? Okay. The recorder's going. You guys are pondering that question that was up there on the board. We'll come back to it in just 1 second. And some of you are maybe even trying to solve it. But you guys saw in homework last night that sometimes we need to use our calculators, right? Okay, so let me open up the book from last night. Let me open up chapter 9. We're going to section 3, even though today is section 4. If I can find section 3. Well, that's not section 3. All right, does anybody have anything from last night specifically? Or we could go back to the other night if we still need to, 3 through 14. But anything first from last night where we got stuck? I think it started around number 17. Is that right? There we go. Anything we need to look at? Are we okay with finding the square root buttons in our calculators or on our phones? Is the square root for your phone is this way, or is it on the extra options that open up in your calculator when you tilt it? Okay. But we know that we can open up that basic calculator. It can, if you tilt, you can get all sorts of stuff. You start seeing like all kinds of letters and square roots. But when you tilt it, were the decimals working out okay? I'm plugging in the square root button to the calculator or to your phone. Give me a thumbs up if you're like, I'm good on homework last night. Okay, anybody who's not a thumbs up, is there anything you want to ask? Any problem you want me to do? 17 to 23, 25 to 28, 31. Yeah. Ooh. Yeah. No, that's a good one, Jeremy. I'm going to use this section real quick in homework to tell you how to do that one. Did you tilt it? Are the other options showing up? Okay, do you see a square root button? Yeah. Go in, clear that out. There you go. You have your 29, and then you need to go find your square root button, which is right. Where's your square root? Does that have a little 2 in it? This one right here. Yeah, hit him. There you go. But it's okay. In homework, guys, how many decimal places are you supposed to round to? The second. Good. It says hundredths and tenths are the first decimal place, so you want to keep 2 decimal places. So like in this one, did anybody else realize the square root of 29 is a decimal? If you're looking at the one that you thought was easy, if you chose that one, the square root of 29 should be 5.39. 5.39. If you didn't have a calculator, you didn't plug it in. But that would have been similar to this section, right? So can I just take the even because you guys, the odds, you could have checked in the back of the book. what happened when you tried to solve for x squared? You guys are all acting like you were good. So what was the very first thing you should have done on number 26? Minus 11 from both sides. But when you subtract 11, is 13 a nice perfect square? No, we could try to break it down, but there's nothing nice. 1 and 1, 2 and 2, 3 and 3. No. Somewhere between 3 and 4, though, because 3 times 3 is 9, and 4 times 4 is 16. It's somewhere between there. But it said nearest hundredth, which meant, okay, if you put your square root in, if you were amazing and were like, hey, I know I'm allowed to put in a radical, a square root to undo the squared. Remember, the radical is gone at that point. A squared undoes a square root. He disappears. The absolute value remains. And why do I have that absolute value again? What is it slowing me down to do? Kind of split it up. The absolute value says, remember, the answer could be two options, right? What are the two options the answer can be with an absolute value? Good. So the way to get rid of the absolute value says you can be the positive or you can be the negative. However, the book didn't say to stop there. The book actually said, hey, you should plug this into your calculator to get a decimal. Now, guys, it depends on your calculator as to where this is. Meaning, some of your calculators, it's like a button that you just hit and you don't even have to do anything crazy. In my big old calculator, like some of the ones in my box, you have to hit like a shift button. It's like a shift button on a computer. It's usually called like a second button, or some of you guys, it's like a, I don't know, it's a color green or something on some of those calculators, or an orange button. But I have to go find the square root because it's not on the main button. It's like a subcategory, so I have to go hit the square root on mine, and then I can type in, sorry, not 29, that was on your worksheet. 13 is the one we're doing. So it'd be plus or minus 3.6, and then we round to the second decimal place, hundredths. And guys, if or since this is a 5, what do we do with that 0? How do we round it? Up. Good. If it was a 4, a 3, a 2, or a 1, we keep it the same, but since it's a 5, or if it was a 6, 7, 8, 9, we round up. So it'd be 3.61. So in your homework, you guys should have gotten x equals, you could have even done that really snazzy plus or minus. What is the square root of 13? 3.60. I wasn't paying attention closely enough. Okay, yeah. Plus or minus 3.61. Okay. Based on homework last night, last call questions. Grading it tomorrow. A's and B's are the worksheets and the homeworks. Okay, so 4 things, 2 worksheets, 2 homeworks. Wait, the worksheets, isn't it really the same paper, front and back? Nice. Go team. Okay, so 1 worksheet, front and back, and then the 2 homeworks. Based on last night's homework, I have a pretty good guess what most of you decided to circle. Doesn't mean all of you did. I saw at least one person that didn't. They chose the other one. But I think most of you would have circled this one. If you did, raise your hand. Let me see. Okay. Yeah. All right. Most of us chose this one. If you chose this one, you're not scared of factoring, and that's actually really cool. If you chose this one, that means you're not scared of factoring. I'm hoping that's one. And that's pretty cool. But if you chose this one, you're like, wait, it looks like homework last night. All I have to do is do what to both sides? Oh, not subtract yet. You're right, we're going to have to, but not yet, because the addition is trapped inside a squared, so I need a radical, right? And just like all of homework, which, I mean, hold on, guys. Hold on. You were like, we're good. We're good. And if you're good, you would have gotten through this entire section, right? And how'd you get through this entire section of homework? What'd you have to do to both sides? Over and over and over again. Radicals, yeah. We had to throw square roots in to undo those squares, just like the worksheets yesterday, right? Because the worksheets yesterday, and you guys were doing okay on them. Didn't we have to? Thanks, Jamie. Sorry, you're stealing your stuff. You had to keep on taking square roots of those little baby squares on 1 and 2 and 3, and I think maybe even 4 and 5. Oh, no, just 1 and 2 and 3 looks like these guys. Where we had these parentheses, but if you square root both sides, then, yeah, then the squared is gone. Then I can do the stuff on the inside, like the adding of the 1, the dividing of the 2, or the subtracting of the 3, or the subtracting the 5 and dividing the 4. But you cannot touch the inside. You can't get in there until you free that whole expression from the squared. And so, I asked you guys, if you circled one, or which one you did circle, I mean, it's not hard to pick one, right? To try to keep going. Did anybody try to take a square root of both sides? And did anybody, write x plus 5 and put the absolute values? That'd be really snazzy if you also put the absolute value. That means that you were paying attention in class yesterday, which is a good thing. Now, with the absolute values, well, you had two options. Last night in homework, wouldn't they have said go get a decimal? Okay, so we could go get a decimal for square root of 29. And Jeremy, you actually found that. What was that? That was 5 point what again?
It was 5.38.
Okay. 5.38. If you want, you could technically, if we're allowed to be getting decimals. Now, this one's not saying keep it in simplest form. If it was, it would just be leaving the radical because 29 doesn't break down. You can divide by 1, by 2, by 3. Nothing goes in. It's a prime number. Only 1 goes in, nothing else. You could try to break it down. It doesn't break down. If we're leaving it in radical form, we would have stopped right there and not gone to a decimal. But since they were saying decimals last night, that's what was in your brain. But that absolute value says, hey, it can be either a positive or it can be a negative. But careful, it wasn't as easy as stopping with the positive or negative square root of 29. What do you have to do once the x plus 5 is free? Yeah, subtract the 5. So to finish the answer, then we would do minus 5. We would do minus 5.
0.38.
Nicely done. That's one of them, but what would the other one be? Because there are two answers. No, actually it's not. There is 0.38, and this is a negative, but it's not negative 0.38. Isn't negative 5 minus 5 negative?
10.
Yeah. Now, some of you saw that, and that's good. But it's going to be really easy for our brains to be like plus or minus, I'm done. No, 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 no. The absolute value says this is a positive or a negative, but when I subtract 5 from this guy, it's very different than subtracting 5 from the negative. Just be really, really careful that you're finding both answers from the positive and the negative way up here. Now, here's the weird thing. Here's the weird thing. If someone chose this side, and some of you are like, no. If someone chose this side, they weren't scared of factoring. Because maybe they would have looked at this and been like, hey, what does everybody have? A 2. And when you factor out a 2, you would divide everything by 2. So that'd just be a 1x squared. That would be a 10x. And this last one would be a 4. Now, maybe some of you guys saw in homework, I don't remember how many I gave to you last night. But that's the wrong one. But in homework, there were a couple where there was a number in front, number 23 and number 24. Did I give either of those problems to you guys? Just 23. Just 23. Did you guys figure out how to do 23? What the first step was?
Yeah.
What was the first step?
Square it.
Careful. There's already a square. The proper term would be square root it. You could square root it. That's just dangerous. This time it was okay. This time it was okay. Other times it would be dangerous with the number in front. Because does 9 have its own square root?
Yes.
Yes. So you could have gone to 3. Square root of 9 is 3. Just good old-fashioned 3. The square root of a squared ends up being the absolute value. You could have gone there. It just was kind of a crazy jump. Square root of 16 is 4. 4 and 4 is 16. So square root of 4 squared is 4. You could have done that. What's usually safer, because this number won't always be a nice perfect square. Ooh, hey. Can we go back a little bit to our worksheet? Can I square root 2?
No.
No. Now, I know this isn't a perfect square. I know it doesn't look exactly like it. I'm just trying to show you I can't square root that. There are sometimes going to be numbers in front that aren't perfect squares, and if that was true, it's actually a lot safer than taking a square root. I know that you saw the squared, but technically there was something before the squared. We're actually doing PEMDAS backwards. We always do with solving equations. For instance, if I was to have on the board, I don't know if I want to take a huge timeout on this, but I do want to take a little timeout. If I have something like 2x plus 1 equals 5, come on, Algebra 1 beginning stuff, even pre-algebra stuff. What's the first thing you undo? The addition, yeah. You have to subtract, right? But doesn't PEMDAS tell me multiplication then addition? But that's when I'm going forwards, not when I'm undoing. When I'm going forwards and I'm trying to simplify an expression, I do PEMDAS, P then E then M, D, then AS. But if I'm undoing an equation, hopefully most of you were like, hey, subtract the 1, because you know we're doing PEMDAS backwards, the addition, subtraction first, and then the multiplication, division. And that's how we would properly, legally solve. Now, that brings us back to our original question over here. Should I be dealing with the exponents before the parentheses, all before the multiplication? The answer is no. If I'm doing PEMDAS backwards, I should undo the multiplication first. And I know some of you don't like that. You're like 16 over 9, that's awful. But at the same time, the same way that we could square root the 9 here, we can square root the 9 in the denominator over there. So technically, we would want to divide first and then get that x plus 1 squared alone and now put in the square root. So in homework last night, some of you were okay, and it worked out fine this time. But in other times, if the 9 wasn't a nice perfect 3 square root, it would have actually messed you up to take the square root there. Let's go back to our notes. The reason I'm saying that, this guy has a number in front also. But I can actually get rid of that number, just like maybe you should have done in homework, by just dividing him on the other side. Angie Bosch, what's up, bud?
So instead of doing it with all the parentheses, could you just have divided it by 2?
You kind of could have. The problem is a lot of people would forget. They would have put the divided by 2 here, but they would have forgotten in algebra you have to do it to the entire side. And unlike addition or subtraction that you just have to do with like terms, multiplication or division has to be done to the whole thing. So they might have, or would have accidentally just done divided by 2, and then this would have still been a 20 when it needs to be a 10. See it? And this would have been an 8 and it needs to be a 4. So it's just dangerous when you try to do the division without factoring it out first. Does that kind of make sense?
Yeah.
Okay. Now, at this point, people who aren't scared of factoring would think of going to what? You're going a little too advanced in the sense that there is a method that would add the 4, but we haven't seen it yet. So I don't know, Levi, if you're tapping into that or if you're just kind of making a mistake with our old way. There is a way, but it's just complicated, and it's what we're starting today. Technically, the old school way would have been like, hey, what are factors of 4 that add to be 10? None. Like, none. Oh, no, it's last chapter. It's a no solution. Just kidding. Nope, there are 2 answers, and they're nasty, and they're decimals, and guess what? They're these ones. No. No. These are 2 different problems. Are they? Are they? They look different, don't they? But are they actually the same? They look different, but are they actually the same? What if I took that x plus 5, and what if instead of square rooting both sides, we had actually FOILed, like I think a couple people told us to do yesterday. Not that they were wrong. It just wasn't the easier way to do it. And what if that's squared? Okay, it means this times this. What if we did the multiplication? What if we didn't get rid of the squared? What if we actually did it? Like we actually multiplied x plus 5 by itself. I'm going to jump ahead a little bit. It's a perfect square. I know a shortcut to solving it. But you guys could have also put it in your table with your x plus 5 and your x plus 5. You would have gotten x squared with a 5x and another 5x and a 25. Which is x squared plus 10x plus 25. Oh, does anybody see it yet? What would happen if we did the old school way of getting 0 and getting it in standard form with a 0 on one side? What's 25 minus 29? Oh my goodness, they are the same! What does that mean? Were you guys able to tackle it when it looked like this? Some of you thought so, but when you went down to factor, you're like, uh-oh, I'm that. Were we able to solve it on this side though? But what's the problem? They don't look the same. So here's the idea of section 9.4 if you guys are note takers or if you're taking them in your actual worksheet. I didn't leave a lot of extra space. Oh, but I did copy and paste part of this. I copy and pasted part of this into your notes so that even if you're not usually note taker people, you can actually write this down because it's so important. Our goal in section 9.4 is to do something called completing the square. And right now it's not going to make any sense as to what those words mean for most of you. But the question is that we're trying to answer. The question is, what is this completing the square thing and can it help me solve tricky ones? And the way it can help us solve tricky ones is basically what you guys just saw. What you guys just saw was an equation in two different forms. One of them, you're like, I can start this. I can square root both sides. The other one, some of you were like, I can try to factor this, but the factoring wasn't nice. And so even though I was really proud of you for being like, yeah, I can pull out a 2 and I can try to factor, and that was great, the problem was it's not a nice factoring problem. But the answer wasn't no solution either. So here's the why to this entire section, and it's going to take us, I think, an A and a B and a C. It's going to take us 3 different days to get there, okay? Which means it's going to be partially this week and partially next week. It's going to take us an A and a B and a C, 3 different days to get there. Why are we trying to get this dude? Why are we trying to complete, which means finish, which means something's missing? We're trying to fill in, we're trying to complete this perfect square trinomial because of what most of you did. You looked at those 2 questions or those 2 forms and you said, I like the one on the right because I can take a square root. The one on the left, you're like, And even those of you that were like, oh, factoring, you still got stuck. You still got stuck. So why are we doing this? Because something squared, and this, like, if you guys notice, there's a lot of space here. It's one of those block squares, like with an x plus 2 or a 2x minus 1. Yesterday I called it a u squared. But if I have a block squared equal to a number, most of you liked the right-hand side, and that's okay because you knew what to do, whereas the other one you didn't. So, are you guys all in a spot where either in your notes or like in that little fill-in on the worksheet, we can actually fill in? I'm going to put an example in here, okay? I'm going to put an example in here, and we're going to try to write out what we're doing. Yeah. What we're doing, and then make like a formula out of it. So here we go. What if I was to give you something like, let's see if I can help out. Let's do. Let's leave this blank for right now, because technically this is what we're trying to get to, not what we have. Okay, what if our example, ready? Let's just do EX for example, the little colon. What if our example was something like x squared plus 8x, okay? And we're building up. We're building up to being able to look at the nasty form of those 2 equations and being able to know how to make it look like the nice form, where we can just put in a radical. If we were doing the multiplication, and if this was the answer coming out of the box, guys, which box would the x squared have been in? Yeah, if you guys ever did, with me, if you ever did multiplication, the x squared was always the guy in the top left, right? Okay, now, if there are only 8 x's, here's what I need you to realize. Isn't there a step 1 and a step 2? What does the step 2 say? Step 1 says, okay, you have this x squared plus bx. And we're like, okay, whatever. The x squared would have been that top left-hand box. What does this bottom one say? Split the x's in half. How many x's do I have? 8. Okay, so imagine 8 x's. Some people even like to try to do these, make it more visual. They have these algebra tiles where they're like, hey, there are these little bars, and there are 8 little bars, and all of them represent some unknown x. I think Mrs. McCrae liked to use those, the algebra tiles. Imagine 8 of any object. If we were cutting those 8 in half, you get half and you get half, right? Like sharing whatever, a brownie with your sibling. It's like, well, better make it half. Or whoever splits it, the other person gets to choose. Do your parents ever do that? No? That was left. It's like, well, you get to cut it, and then like, hey, you get to choose which one you want. But if we have 8 of these and we're cutting them in half, how many are now in each person's hands? No, cutting them in half. You have 8 of them. 4 and 4, right? 4 and 4. Cutting them in half, dividing by 2. Do I have 8 x's total?
Yes.
Yeah, I totally have 8 x's total. If this was true, if this came from here, our question that we need to answer for tonight's homework and basically for the rest of the worksheet is what would have been in this box? 16. I wish there was a 16, so I'm going to complete the square. See it? I'm literally filling in the square with something that's not there. I'm saying I wished it was a 16. I wished it was a 16. Check it. I split the x's in half. I got 4 and 4. And what did I do with that 4? I squared. So if we were writing like little baby formulas, I'm going to go ahead and change the pen. The red was like the example. Let me change to blue. Wow, there are a lot of lights on this morning. Does anybody else feel like it's really bright in here?
Mm-hmm.
Oh. Someone else turned on the lights for me. They turned them all on. Here's what we're going to do. We're going to take the B, and we're going to cut them in half. Okay, that's literally what we just did. We figured out how many x's are there. There are 8 of them. Who was that 8? Some of you work well with formulas, so I'm showing it. That 8 is also known as a B. We're going to take those x's, we're going to cut them in half, and then once we cut them in half, we're going to simplify and then square. And that is how we find C. If you guys look at the directions for both 1 and 2 and 3 and 4 and 5 and 6, doesn't it say something about find C, where there's like a C that's missing that they want us to throw in? This little box right here, this little completing of the square is who we call C. And how we do it is we say, okay, hey you, how many x's do you have? Cool, let's cut you in half. And when I cut you in half, there we go. I'm going to square you. And that's what I wish filled the box. Or that's what I'm going to make fill the box. In these problems, it's kind of like something's not there that we wish was there. And for right now, we can look back at those 2 examples from the beginning of class and just remember, this guy, wherever he is, here he is. This guy had that nice squared, so I could just throw in a radical. This guy didn't. If nothing else, just think. We would like it, especially with these nasty decimal ones where factoring doesn't work. We would like it to look like this so I can actually solve, rather than looking like this where I'm like, I don't know. No clue. I tried and I don't know, even with factoring. So if nothing else, just think in the back of your mind, it doesn't look right. We want it to look like one of those perfect square guys. And we're building up to it. We're not going to really be able to use this to solve all the way until tomorrow. But let's go ahead and check out what these problems are asking us to do. Right now, we're just trying to complete the square. Now, guys, did I give you guys little squares that you could fill in if you want to? I did, right? On 1 and 2 and 3 and 4 and 5 and 6? Okay. In each of these, you don't have to use the squares if you don't want. There is a formula for how to find C. And that formula for C is take half of B and square it. I put it in words in the notes. I think it's even on your paper. You're going to split the x's in half and then square, and that's what C is always going to equal for each of these. If you guys want right now, for each of these, C equals, C equals, C equals. That's our job, that's our goal. But if the square helps, look at the problem and say, where would the x squared go? Top left, right? Hey, is that the same for number 2 and number 3 also? Mm-hmm. Fill them all in. All of them have x squared. Hey, how about 4, 5, and 6? Do they have some x squareds too? Mm-hmm. Fill them all in. That top left-hand corner is always that squared term. That top left-hand corner is always that squared term. So just like we filled in the x squared from here, as long as each one has an x squared, I can fill it in on every single problem in that top left-hand box. I can fill it in that top left-hand box. But here's where we need to get the C. Remember, it's this box right here that we're trying to figure out, and that's where the C comes from. We have to take the negative 6x or the negative 10x or the 2x and cut it in half. If we were to say, you get half of them and you get half of them, how many would each box have? Negative 3. He would have negative 3x, and he would have negative 3x. To cut it in half, they have to have the exact same number. Does that make sense? Okay, go do that for numbers 2 and 3. Can you guys split up negative 10x and split up 2x? We haven't technically completed the square yet, but man, we're well on our way to be able to rock this homework tonight. This homework tonight has the exact same directions as the ones that you guys see us doing right now. Find C, and then we'll see what 4, 5, and 6 is talking about. Do you guys fill in your x squareds? Good. If you were taking those negative 10x's and saying you get half and you get half, how many are in each? Negative half. Rocking it. Now this one might actually be a little bit hard. 2x? 1x. Okay. You could have done 1x or you could have just done x. Either way is totally fine, right? Okay. But remember, all of this was just set up to say, okay, I see the square, what's missing? We put in the x squareds. We split up the middle terms, or the b's, half and half in each of the other boxes. So then, see if, once we split them up, how do we fill that last box? What's the words to number 2 up above? Split the x's in half and then square. So, we have negative 3, and we have negative 3. What's negative 3 squared? It's as easy as that. Dun, 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 dun. Wait, that's it? Just 9? Just 9. That was it. That's all we had to find. Just 9 for today. Just 9. Wait, some of you guys are like rocking it now. So what would the next one be? Oh, man. So you'd be like, you were going too slow. Well, now I'm not. Hold on. What's this one going to be?
1.
Because 1 times 1 is 1. Oh, my goodness. That's not bad, right? Now, the formula can look so confusing. Like, seriously, the formula can be like, what? But if you realize it, we're just seeing how many x's do you have. We have to split them in half for a perfect square trinomial, which you'll see more tomorrow. Split them in half and then just say, oh, hey, to complete the square, that should have been a positive 9. That should have been a positive 25. Now, the x is gone, remember, because, well, wait a minute. Let's go talk about 4, 5, and 6 real quick. Because for 1, 2, and 3, we're done. We found C. For 4, 5, and 6, doesn't it bring in another word that we haven't talked about at all today, really? Factoring. Now, I'm going to talk about that, but I think there's a question on the page. Yeah. What's up? Oh, I thought someone's hand was up. You guys are good? Good, good, good. The word factoring comes up. What's different in 4, 5, and 6? So many things are the same. Oh, wait, there's no plus C. Like, it's not even on the page, right? 4 doesn't have a plus C, 5 doesn't have a plus C, 6 doesn't have a plus C. But question, what do the directions still say?
Complete.
Oh, wait, whoa, they're not even, hey, check it. What were we doing when we found the plus C? We were finishing the square. This is literally what these words mean. We were finishing the square. So can you guys write here when it says complete the square? Can you guys write down find C? Because that's literally what they mean. It's just the snazzy math terminology for it. Complete the square. Now, technically complete the square is the whole process. We're just learning the beginning step to the process, but that's okay. Tomorrow we'll put it all together. But complete the square. Some of you guys are already doing it, and some of you didn't realize because like, there's no plus C. I know there's not a plus C, but what they mean is figure out what you want to be in this spot that's missing. They've made it just a little bit more realistic because up above in 1, 2, 3, they were like, hey, what if there was a C? What should it be? This is really what problems are going to kind of look like, and that there's no plus C, and you're like, ah, stink, I need it. Not plus 4. Does anybody have the right one for number 1? We'll figure out this factoring in a second. 100, close, but not quite. You didn't split that 10 in half, because what should be in each one? 5x and 5x. Take your time, split it in half, and now say, oh, 5 times 5 is 25. That's not your number. Oh.
No.
Yeah, I'm so confused.
Did I not copy and paste those? Oh, no. Okay, let me get the right problem in. No wonder you guys are so confused. So maybe you were right and I was totally wrong, huh? Hold on.
No, they were so wrong.
Like the problems are just different, right?
No, because like, they said 1,000. Somebody said 1,000.
Well, right. Well, someone was looking at mine and they tried to do 10 times 10. It's okay. You guys just need to tell me what is there. So what's the problem that's there? X squared minus 4x. Let's just get all of them real quick. So x squared minus 4x, that's your number 4.
X squared minus 28. X squared plus 26.
X squared plus 26. X. Okay. So, wait. Yeah, you guys might have been really good because if you split up negative 4x, what would be in each box? Negative 2x and negative 2x. So you cut the x's in half and you ask, what's that coefficient? Negative 2. And what's negative 2 squared? 4. So that's the first step, is to complete the square. But then factor. How do they expect me to factor? Wait. I have my box. If you factored with boxes, you are so ready to go right now. If you didn't, actually, it might be a little bit harder for you. But still not impossible, because you could do your x method with a 4 and a negative 4. But either way, I have my box and I'm ready to pull out. Kayla, you saw it, right? What comes out of this? X. And then also, I'm just pulling both my x's out. And then, it's not just a 2, though. It's a negative 2. It says factor because once you've completed this square, you've made it into, check it. You've made it into a perfect square. And remember at the very beginning of class, you liked the one with the perfect square because that you could do a radical too. So then have you guys kept going to number 5? What does negative 20 split up to be? What should fill the box?
100.
Good. So if we fill in with 100, what would the factors be? X minus 10 and x minus 10. If you've been factoring with the box, it's like, I see it, it's right there. And this is the answer, guys, to number 5 or to number 4. Now, remember, keep this worksheet close when you do homework, because if you read these words, like how many of you would have known what those words were even talking about? Like, what? I don't even know. But if you're like, oh, I'm literally just, well, let's do the last one. X squared split up 26, and what does it become? Okay, that was a little bit harder, but yeah, 13 and 13. What did we learn yesterday about 13 times 13? Do you remember? 169. But the nice thing is, I don't even really have to do this math in my head. Because has anybody seen the pattern of what always happens with the factors? Yeah. They're always being squared, so I can already put that squared out there. And who ends up being with the x at the end of the day? The same thing as what 1/2 was. Now guys, here's the homework for tonight. It's just 5 through 16. But I also told you guys I was going to try to have up on the board, it's over on the sideboard too, the actual page itself so that you guys could take a picture of it if you want. I wish I was like, I don't know, 2 minutes quicker, but that we didn't have a pep rally today. But I'm going to put it on the screen real fast if anybody wants to grab a picture of these problems. There they are, 5 through 16. If you want to grab a picture, that's homework tonight. If you want to grab a picture, that's homework. Find C, complete the square, and factor. Alright guys? You didn't keep that worksheet close. It'll help us so much. We're grading all of 9-3 tomorrow. If there are those homework problems, work on them at any point during the day. Maybe come with me with questions.
Still like,
Yeah, if you guys need the schedule, it's on the board too.